Hey everyone, Mr. G here. Now that we've gotten the general idea of exceptions about, let's talk about the raise function. So, raising exceptions. So when an exception comes up, we say that the exception has been raised, which is another way of saying brought up. A traditional programming word is thrown. We throw an exception. Seems kind of weird, but in this case, we really want to hone in on the word raise because raise is a key word that allows us to bring up exceptions ourselves to potentially preempt issues that we think could come up in our code. So let's talk about raise. In Python, we have the keyword raise to initiate a reference to a type of exception. So we have to say raise, and then we have to give it a type of exception to raise. This could help us pinpoint where issues might come up because we're trying to predict them in advance. So we're going to go back to our classic example, the zero division error exception. And we're going to try and raise an error for that when we think it's going to happen. So here I create a function called divide, and it just takes in two integers. It's going to divide them, send a float back. And we actually check, is b, what's going to be the denominator, the thing we divide by, is that equal to 0? If it is, we want to raise, so we want to bring up a zero division error exception. And inside here, we get to put a little message. So instead of, we had a very standard message, if we go back to exceptions, we had a standard message that would pop up, division by 0. That pops up every time zero division error happens. Here, we get to write our own short message, which we might be able to use to give ourselves more information. So here we give the custom message, we can't divide by 0, which is obviously not very different. It's not giving us more information, but this is just an example. So if this is the case, we're going to raise this error. If we get past that, if b was not 0, we don't hit the raise, and we're going to return a over b. Everything's going to work as normal. And then down here, I say I'm going to create a variable c. We're going to plug in divide of 5 and 0, which we expect to cause a problem. Now, the result of this is what we'd expect. It's a zero division error, but we notice it gives our nice custom message that we put in when we raised our exception. And the traceback and things like that don't necessarily change, but we do notice that where the problem occurs isn't when it actually tried to do it. It's us catching it in advance and doing raise. So it's saying we started by calling divide, and then we ultimately caused this problem by raising a zero division error before it would have popped up itself naturally in the very next line. So let's talk types of exceptions. There's a lot of different types of exceptions, and we're not going to cover all of them. Most people don't know all of them. I don't know all of them, but we're going to cover some key ones that are probably going to come up pretty often. So there are all of these. You'll notice they all end in error with some other word. So let's walk through some of them. So first, in index error. So this happens when you're trying to use an index. So this is going back to our iterables. That's not actually in your iterable. So the example here is I have a list with 5 elements, and I try to call the 10th element of the list. That doesn't make any sense at all, right? If there's only 5 elements, there is no element 10. And sure enough, when we try to do this, we get index error, list index out of range. So 10 is not a compatible number for this list. A key error is very similar. It's different in that we're working with dictionaries. Dictionaries don't use indices, they use keys, but it's about the same premise when a key is not a part of a dictionary. So here I have a dictionary with A, B, and C as keys, and I try to call the element with key D. And here we get key error, and it tells us which key caused the error, D. We don't have a key D to work with. So index error and key error are both similar. They work with iterables, and they're when the value we provide did not fall into the bounds that we've provided. A name error. So this happens when you try to utilize what we call a local or global name that Python doesn't know about. A name could be a variable, it could be some kind of object that we would refer to via a name. So here's an example that would cause a name error. Without any context, if I just said print name, note that name is not in quotes, so it's supposed to treat name as some form of variable representing something to be turned into a string and printed out. It doesn't know what that is. It's never seen name before in its life. And so here we get a name error, and it says name is not defined. it has an issue because it doesn't know what we want it to do with name. And again, this could have been any random variable name that we haven't used yet in the program. It would give us the same problem and say it is not defined. All right, next is an overflow error. Overflow errors are a little less common than they used to be because we have a lot of storage now, a lot of memory. It used to be that we could only store numbers so big because we had very limited memory, but now we have not necessarily unlimited, but a lot, so it's harder to come into an overflow error. So this happens when an arithmetic operation produces a variable too large for the computer to represent. So this has got to be some enormous number. In most languages, it could occur with integers or floats, so that's something to keep in mind. But due to how Python handles integers, this will never happen with integers. You might run into other problems. There's memory errors, but it won't cause an overflow error. And so we're only going to pay attention to floats in this case. So here's an example. This is an absurd value. I want the variable num to be the number 2.5 times its exponentiation, so raised to the 1,000,000th power. So we want to multiply 2.5 times itself 1,000,000 times. This is going to be extraordinarily large. And look at that, when we run it, we get an overflow error, and it says result too large. So it tells us the number that we are asking for is too big for it to be able to hold on to. So that's an example of an overflow error. A type error occurs when you try to perform operations on types that aren't compatible. So here's a really simple example. I want num to be 2 divided by the string hello. That doesn't make any sense though. We've never really divided numbers by strings before or anything like that. So when we go to do it, we get an output, we get a type error, and it says unsupported operand types for division, int and string. Mostly the problem is with the string, but it's saying that these two can't work together even in a division operator. Next on the list, we have a value error. So this occurs when an operation or function receives a value of the correct type. So if it asks for an integer, we give it an integer, but it's not a value that it can perform the job on. So here's an example. In math, we have the idea of a square root. So we imported the math package here, and I'm just calling the square root function. But we know in math that we can't take the square roots of negative numbers, at least not and still get something like a float back out. We start getting into imaginary numbers. So when we try to call this square root on -1, it tries to take the square root of -1, it returns a value error, and it says math domain error. So that's telling us that this math function is not supposed to work on numbers like -1. And our last type is zero division error. We've seen this a few times now. When you try to divide by 0, you get a zero division error. Any of these exceptions that we covered, you can use the raise keyword when you might expect them to come up to help preempt or understand what's happening in your program. All right, now one more section we're going to talk about handling in the next video.